Hello everyone, I'm Aaron from DataStax, and today I'm going to take you through building applications with Langflow on Enterprise Cassandra. All right, let's go. So real quick, to support the work that we're going to be doing on Langflow, let's build a DSE cluster on the background here. I'm going to call this cluster test for echo. And it's going to be a DataStax Enterprise cluster. We will use version 6.9.2. That should be fine. For a data center name, let's just call it driven. And yep, control plane is fine. Rack name, we'll say R30. Let's go node affinity label of mission control datastax.com/role. And we're going to enter a value of database to make sure it ends up on our database nodes in our Kubernetes cluster. And we want 3 nodes per rack. 4 gigs of RAM is fine. We'll go on GP2 storage with 20 gigs of disk. That should be fine. Give it a super user password. All right, 4 gigs of RAM, so we'll go 2 gigs on the heap. And we will, in fact, deploy the data API because that's how we're going to work with our cluster in Langflow. And we'll create. And then we'll wait for the nodes to come up. Okay, all 3 nodes in our cluster are up and running. So we do have a small 3-node DSE 6.9.2 cluster. Let's have a look at it. So I'll say kube control, get pods, and then for my namespace. And sure enough, we have our test for echo driven R30 cluster right here. So everything looks like it's running well. Let's do, actually, let's just up arrow that and say get. Okay, so the services in our test for echo cluster, we have our data API service right here. That we're going to want to expose. Let's go ahead and do kube control expose. And then we'll say test for echo driven data API service and paste that in there. We're going to expose that as a type of load balancer. And we're just going to call that -lb. And let's get our namespace in there as well. 8181. And also a target port of 8181. Oh, you know what I forgot? I forgot the word service. There we go. Now when I go ahead and do a kube control get services again. All right, there we go. So we have our endpoint for the data API right here. And of course, don't forget, that's on port 8181. So let's copy that off and hang on to that for a sec. Okay, now we're pretty much done with our DSE cluster. So let's shift gears here over to Langflow. So the first thing that I'll need to do is pull down the Langflow Docker container. And that's going to be Langflow AI, Langflow, just like that. And that should grab the latest version of that image. Okay, we have that container image. Okay, so now as you can see inside my Docker desktop here, I do have this Langflow AI, Langflow image here. And you can see that it was created 29 days ago, but you know, that must be in there from when I originally like tested this all out. So what we have to do next is retag our local image of Langflow so that we can send it to our Amazon ECR, or Elastic Container Registry. So let's go ahead and do that. So I'm going to, well, let's clear that. Let's do a Docker tag, and we're going to want to use the current ID for that Docker image. I'll just paste that there. And then I'm also going to paste in the URI of my ECR cluster, or ECR repository, I should say. And then we want to do a :Langflow, just like that. Okay, so now if I have a look at Docker Desktop again, yeah, we have, this is the one we had before, and now we've retagged it so that it'll go to our ECR registry. Before we do that, though, we need to make sure that we're logged into AWS. So let's do an AWS ECR get login password, and we want US West 2, and we'll do a Docker login username of AWS, password standard in, oh, no dash there. And then we'll also paste in our ECR URI again, and then just backspace over the name of our repository. Let's see if this gets us a login. And it does. Outstanding. Okay, so we've pulled the Langflow Docker image down, we've retagged it, and now we've logged in to AWS. So now let's just go ahead and do a Docker push, and we want to paste that again, and then we're just going to say Langflow. That should do it. Okay. The Docker image for Langflow has been pushed to our AWS ECR repository. So let's go have a look out here. Jump over to ECR. And we'll use the reinvent repository that I'd created. And oh, look at that. We have Langflow, just like that. Okay. So with that image out there, what I'm going to do is copy that image URI, because I'm going to need that in a little bit here. Now let's go back to the Elastic Container Service, or ECS, and into the reInvent 2024 cluster. And what we're going to do is create a new task. So I'm going to call this Langflow, just like that. And we'll keep it on AWS Fargate. All right, we'll just leave it on Linux x86. Yeah, 1 CPU, 3 gigs of RAM. And maybe we'll bump that to 4, huh? Okay, for container, we're just going to call this Langflow. And here's where we paste in our image URI. This is indeed an essential container. Now, Langflow requires that you have a specific port mapped, and that is the port 7860. See, we shouldn't need any environment variables or anything. Yeah, I think the rest of this is okay. Okay, so we have a new task. And now what we can do is we can deploy this task as a new service. So we'll say create service here under deploy. Yep, it's going to go in that cluster. Yep. It is a service, not a task. There's the task definition. We're just going to call this Langflow. And I'm going to go down to networking. And my default security group does not have 7860 open. So I will need to grab a security group that does. And this specific one that I created for our demos at AWS reInvent does have 7860 open. And that should do it. All right, let's hit create. All right, so now I can watch the Langflow service deployment take place here inside of ECS. I can go into that service itself. I can have a look at the task. There we go. Our task is out there. It is provisioning. Okay, there you have it. Our Langflow task is indeed running as a service. So let's go click into it. You can see that it does have a public IP address here. So I'm going to copy that. And then we're going to say HTTP // there's our address. And then we can say 7860. And if we did this right, we should see Langflow come up. All right. There it is. Look at that. We have Langflow running out in our AWS account in US West 2. So that has both our DSE cluster and it has Langflow. So now let's go ahead and start building. So I can hit this new flow button right here, right in the middle. And I want to go with a template of vector store rag. So let me click that. Okay, and you'll see what it does is it creates two separate flows inside this this Langflow project here for vector store rag. First of all, let's rename this. I'm just going to call this an AI shopping assistant, just like that. And we'll go ahead and save. So on the top here, we have the chat flow, but the chat flow is really only going to work once we have data and once we have vector embeddings in place. We don't have that just yet. So let's have a look at the data loading flow to get started here. So I'm going to start by using a file here for my data, and I have this this product data file, products2.csv, and it's from a webinar workshop we used to do on building an e-commerce site a couple years ago. Anyway, so I have all the product data out there. So let's go ahead and use that. Text splitter is fine. You know, maybe we'll lower the chunk overlap by a little bit. Now, the default vector store component that ends up out here is DataStax AstraDB, but that's not going to work. So for us, what we want is we want to go to vector stores, and since we're using DSE, we want to go to DataStax Hyperconverged Database. This is going to allow us to connect to our DSE cluster using the data API, which is what we want to do. So let's go ahead and get rid of the AstraDB connector. We want our chunks going into ingest data. Maybe we'll even slide that over a little bit. For our collection name, for those of you who have used Cassandra and DSE before, collection is analogous to a table. We'll say shopping assistant vector data, just like that. Remember back earlier in the video when we created a load balancer on the data API? Here is where we're going to paste in that endpoint. So I'm going to go back to my notes and copy that and then paste that endpoint right there. And then I'll even hit the the view button here so you can see, yep, there's my API endpoint. And yep, and it goes for my load balancer and it goes to that US West 2 ELB Amazon AWS.com, just like that. Okay, now if you remember, the name of our super user is test for echo super user. All right, and then we can use the same password that I had generated at cluster creation time. All right, so that's all in there. Next, we need to generate our vector embeddings. And to do this, we could use OpenAI, but since we're kind of sticking with Amazon here, let's go ahead and get rid of OpenAI and then grab Amazon Bedrock instead. I am going to paste in my secret access key. And then I'm also going to paste in my access key ID, just like that. I shouldn't need to worry about session token. I will, however, specify US West 2 as the region. That's actually where I've gone ahead and enabled access on the Titan embedding text v1 model. And we're all working in US West 2 anyway. But now what I'm going to do is connect this embeddings node to this other embedding or astrovectorize node, right? Just like that. Okay, now we have our data loading flow. So before I test this out, let's actually jump back to mission control and have a look and just kind of verify that that it's empty, so we can kind of watch this happen in real time here. All right, so I'll go to mission control. I'll say CQL console, and then we'll say test for echo super user. Okay, we're connected. Let me do a desk key spaces. Okay, so as you can see, we really only have the default system key spaces in here right now. So if I go back to Langflow and I click the Run Component button on my DSHCD vector store component, this should go through everything and load our data. Oh, don't forget, on the end of the load balancer endpoint for the data API, we need port 8181. And we need HTTP on the front. Let's try that again. Oh, and we're missing our default namespace. We have to create that first. So let's go back to mission control. Let's have a look at the system auth key space. All right, and if I scroll back up here, you'll see how we've created the system auth key space with the network topology strategy and 3 replicas in the driven data center. So let me copy that, and then we'll say create key space, and it was asking for it to be named default namespace. That's what we want to name this. So let's say default namespace, and then we'll paste. There we go. Now we can say use default namespace, and then describe key space, and there we go. Okay, now we can jump back to here, and now we can rerun our data loading flow. Okay, that completed successfully. So now we're here, and we can say desk tables, or actually, I can just redo the desk key space command, and you'll see it has created this new table called Shopping Assistant Vector Data, which through the Data API is known as a collection. You'll notice it has all of these custom indexes on it to kind of help it through the vector search functionality. And then if you look here, you can see that we have our query vector value, which is a vector float 1536 to match with our Titan v1 embedding model. So now if I select star from and shopping assistant vector data, you can see that we have 24 rows out here. So our data is indeed loaded. All right, this totally worked. So Now let's go back to Langflow. And what we're going to want to do now is go to our chat flow next. So some things to note here. First of all, you notice we still have a vector store component for AsterDB, and we still have an embeddings component for OpenAI. So let's replace those right off the bat here. So we'll go delete there, and go delete here, just like that. Now, if I go back down to my DataStax HCD component, I can say duplicate. And then we can grab this and go back up here. Now let's go ahead and run message to search input and then search results to data, just like that. Now, of course, we also need our embedding model. We're not going to get far without that. So let's go back to Amazon Bedrock. Same thing, we'll say duplicate and then grab this component. We're going to go put that right here. And then we can go down to embeddings and connect up our vector store component, just like that. We can make our way through. Inside the prompt, we're going to want to add a little bit here. So let's say you are a shopping assistant for the Astra Apparel online store. You may only use the data from the provided context, and you, let's see here, you must format your responses like this. And we'll say product ID, description, and image. Okay. So hopefully these are good enough guardrails to keep our AI shopping assistant on task and providing consistent responses. So let's do a check and save. Okay. Next, we have to modify our model here, because right now our LLM chat model is using OpenAI. So let's get rid of this. And then for models, we'll grab Amazon Bedrock. Okay, so prompt message, we'll go to input and text to text, just like that. Let's see here. Let's go to Claude 3 Sonnet. And then we'll also put my, let's pick the right region, US West 2. And then let's also make sure that we have my AWS access key ID and secret access key in there as well. So let me go get those. Okay, we should be all set now. But just for testing, let's start out with chat input here. Normally you want a good seed question for testing. And what is this document about isn't going to be that good. So we'll say, can you help me find a purple shirt? Perfect, just like that. So let's go ahead and adjust our prompt one more time here. Case in point, we're going to want to make sure that we have this context variable here in braces. Between the context and the guardrails that we've provided, this should do it here. So now if I say check and save, you'll notice that we have a connection node here for context. So now what I can do is go from text to context, just like that. And now we should be able to run our playground here and see this build. Okay, built successful. Let's check the playground. Oh, look at that. Can you help me find a hoodie? And it actually brought back this data right here. So then we could say, can you help me find a Cassandra shirt? Yeah, here we go. Cassandra shirts available. Well, okay, so it found one with a bunch of different sizes, but you could certainly trim this down on your own. Yep, 2023 Cassandra Summit. Here's another one. That's the Cassandra 3.0 contributor T-shirt. So you can totally shop for products conversationally here. So yeah, that is how to build with Langflow on top of DataStax Enterprise out in AWS. All right, that should do it. Want more information on modernizing your self-managed Cassandra deployments? Head on out to datastax.com/modernize-apache-cassandra-workloads, and you'll find all the information you need on keeping your self-managed Cassandra cluster updated and in top running form. Thank you, and have a great day.